welcome to the new. Good morning, students.
Good morning, ma'am.
Good morning, ma'am.
Good morning,
Good
ma'am.
morning, ma'am.
आप लोगों को पोस्टर
Say good morning.
कंपटीशन की क्लैरिटी है सब? गुड मॉर्निंग मैम. पोस्टर कंपटीशन की सब क्लैरिफिकेशंस है ना आप लोगों के पास?
Say yes.
Yes, ma'am.
पूछो डाउनलोड ये
So as
कैसे
per
डिस्कस
the
करें?
categories, students just listen. As per the category 1, 2 and 3, ठीक है? 1, 2 and 3 के अकॉर्डिंग आपको डिफरेंट लिंक्स मिलेंगे, ठीक है? So you people have to join the corresponding link. और जब आप अपना पोस्टर ड्रॉ करना स्टार्ट करेंगे, सबसे पहले जो आपको व्हाट्सएप ग्रुप पे इंस्ट्रक्शंस मिली हैं, वो नेम, अपना कॉलेज, अपना क्लास, रोल नंबर सब उसके ऊपर मेंशन करेंगे, इंक्लूडिंग कैटेगरी, ठीक है? कि आप कैटेगरी 1 मींस इफ यू आर बिलोंगिंग टू द स्कूल लेवल तो आप कैटेगरी 1 में हैं, इफ यू आर बिलोंगिंग टू एनी बीएससी बीटेक कोर्सेज तो आप कैटेगरी 2 में हैं, और पीजी कोर्सेज टू द यूनिवर्सिटीज कोर्सेज जो हमारे पास है या किसी कॉलेज में किसी पीजी क्लास पे हो तो कैटेगरी 3 पे आप आएंगे, ठीक? फिर जिस भी थीम पे आप काम कर रहे हैं वो थीम आपने मेंशन करनी है, इफ पॉसिबल अपने पोस्टर को एक टाइटल दे देना है, ठीक है? और जब आपको लास्ट में कॉरेस्पॉन्डिंग टू योर कैटेगरी यू विल फाइंड अ लिंक, आपको एक लिंक मिलेगा जिसमें आप हाई क्वालिटी इमेज उसका क्लिक करेंगे और उसमें सेंड करेंगे गूगल फॉर्म में। तो गूगल फॉर्म में भी सेम एंट्रीज आपको फिल करनी पड़ेंगी, इंक्लूडिंग कि आपका थीम क्या है और टाइटल क्या दे रहे हो, व्हाट द टाइटल यू आर प्रपोजिंग टू द पोस्टर यू आर ड्राइंग और अंडर विच थीम यू आर ड्राइंग, ठीक? तो वो आपको सब मेंशन करना है। और दूसरी इंपॉर्टेंट बात, जजेस पैनल विल जॉइन अस in between when you are been drawing, so in between they can ask what you are been drawing, ठीक है? तो आपको थोड़ा बहुत वहां पर उन्हें बताना भी पड़ेगा कि this is your theme and that's why you are been designing your poster in that way. क्लैरिटी है ना? इस तरीके से आपने वर्कआउट करना है। अब आप पूछिए अगर कोई डाउट है बिफोर वी कैन स्टार्ट द लेक्चर। हमारा जो लेक्चर है पहले वो 11 o'clock स्टार्ट होगा, you will find it will be very wonderful lecture, तो उसे ध्यान से सुनिएगा ताकि आपको आगे की ये मोटिवेशन भी मिले और क्या क्या हो रहा है। टुडे वी ऑर्गेनाइज द लेक्चर रिगार्डिंग द टॉपिक स्पेस साइंस एंड टेक्नोलॉजी, ठीक है? तो कोशिश कीजिएगा कि आप जब ड्रॉ कर रहे हैं तो योर कैमरा इज बिन फोकसिंग ऑन योर शीट एंड सो दैट हम वहां देख सकें, और अगर कोई और आपके बिहाफ पे कंट्रोल कर रहा है कैमरे को, या 2 लोग जैसे मैं देख रही हूँ प्रवीण राजपूत, टू विच स्कूल यू आर बिलोंगिंग?
Parveen is educator.
ओके, प्रवीण इज एजुकेटर एंड आप कौन से
These two are students.
दैट्स व्हाई आई एम जस्ट आस्किंग कि 2 स्टूडेंट्स हैं तो दोनों के ऊपर फोकस करने के लिए इफ somebody is been playing with the camera तो वो एक एक के पोस्टर को फोकस भी करें।
ठीक है मैम, ठीक है, हमारी कोशिश रहेगी।
अदरवाइज आप हाँ कोशिश करिए कि 2 से ज्वाइन कर लें, क्योंकि ऐसे दोनों को देख पाना ड्यूरिंग द पोस्टर, आप जब लेक्चर सुन रहे हैं देन इट इज फाइन, बट एट द टाइम ऑफ ड्राइंग एंड पेंटिंग व्हेन वी आर बीन लुकिंग एट द पोस्टर तो हमें दोनों का दिखना चाहिए।
ओके मैम।
और भी कोई क्वेरीज हैं यू पीपल कैन आस्क एंड वी विल स्टार्ट शार्पली एट 11 फॉर द लेक्चर।
मैम पोस्टर के ऊपर भी हमने कोई नेम वगैरह या टॉपिक नेम भी लिखना है?
कोशिश कर लो एक बॉर्डर लाइन बना के आप लोग कर लीजिए, ठीक है, ताकि हमें
क्लैरिटी ठीक नहीं लगेगा मैम वो।
ओके,
तो मैं
बैक साइड पे आप जरूर लिखिएगा, आप हमें तब उस टाइम पे शो कीजिएगा।
मैम हमें टॉपिक कब पता चलेगा कि हमें किसके ऊपर बनाना है?
टॉपिक तो ब्रॉड टॉपिक्स हमने आपको दे रखे हैं, फ्लायर में आप लोगों ने देखे होंगे। ब्रॉड टॉपिक्स
मैम उनमें से किसी एक के ऊपर बनाना है?
हाँ, मैं एक बार डिक्टेट कर देती हूँ। ब्रॉड टॉपिक्स और एरिया: क्लीन एंड ग्रीन एनर्जी, food safety, health safety, medicine area means you can say healthcare, sustainable environment, fourth topic है energy harvesting और energy storage, fifth है women in STEM का फुल फॉर्म आप लोगों को पता है ना, STEM means
Yes, ma'am.
science, technology, engineering and mathematics. ठीक है, तो women in STEM. Then है हमारा one of the important is Indian contributors in science. Then artificial intelligence, Internet of Things for science and technology. These are the broad topics. Yes, Shivender, you are raising your hand.
एक्सक्यूज मी मैम,
हाँ रुद्र बोलो.
हेलो मैम।
तो कैमरे का फोकस है मैम वो पोस्टर पे होना चाहिए मैम। मैम जो कैमरे का मतलब फोकस है मैम वो पोस्टर पे रखना है।
हाँ, अगर आप फोकस आप पे भी हो और कैमरे पे भी, जैसे आप लोग ऑनलाइन एग्जाम देते हैं तो वी कैन इजीली व्यू आउट कि आप क्या लिख रहे हैं स्क्रीन पे, तो सम लाइक दैट
इसको मैं साइड में रखता हूँ।
यू आर ड्राइंग, ठीक है, एंड व्हाट यू आर ड्राइंग, हम वो चीजें देख सकें.
ओके मैम।
ठीक है, तो आपके पास थोड़ा सा टाइम 5-10 मिनट हम
Hello.
देंगे सो दैट यू कैन सेट योर कैमरास. यस शिविंदर, यू प्लीज.
मैम व्हाट इज द टाइमिंग फॉर द कैटेगरी 3?
सबका सेम टाइमिंग्स होगा, सबका टाइमिंग सेम होगा. पहले हमारा
Time.
लेक्चर होगा बच्चे, 11 o'clock लेक्चर विल बी स्टार्टेड एंड 11 to 1 hour 1.5 तक का हमारा लेक्चर हम मान के चल रहे हैं. तो पॉसिबली 12:30 पे हम ओवर हो जाएंगे लेक्चर से एंड देन आफ्टर कंप्लीटिंग ऑफ द लेक्चर वी विल स्टार्ट ज्वाइनिंग द रिस्पेक्टिव ग्रुप्स कैटेगरी. तो आपको है उनका गूगल लिंक आप लोगों को मिल गया होगा. ठीक है,
Yes,
के
ma'am.
लिए मैंने गूगल लिंक का इनविटेशन भेज दिया है आपकी ईमेल पे, डायरेक्टली यू कैन ज्वाइन. ठीक है, एज पर कैटेगरी 1 और कैटेगरी 2 के लिए अगर मैं आपको बताऊं, कैटेगरी 1 में डॉक्टर सुनीता दलाल एंड डॉक्टर अंजू विल असिस्ट यू, एंड फॉर कैटेगरी 2 फॉर यूजी स्टूडेंट डॉक्टर उर्मिला एंड डॉक्टर पूजा, एंड फॉर कैटेगरी 3 मी डॉक्टर सुमन महिंदिया एंड डॉक्टर सुरेश. ठीक है,
यस मैम।
मैम,
यस कविता बोलो.
क्लीन एंड ग्रीन एनर्जी भी इंक्लूड है टाइटल.
हाँ हाँ, क्लीन एंड ग्रीन एनर्जी भी इंक्लूडेड है. मनरूप, अच्छा मनरूप आपका हैंड रेज है.
एक्सक्यूज मी मैम।
हाँ आशीष,
हाँ मैम, सबका ही ये टाइटल है कैटेगरी 3
सबके
में
लिए
भी?
कॉमन है. हाँ सबके लिए कॉमन
Clean
है.
and
इट इज
green.
अप टू योर चॉइस कि आप इन टॉपिक्स में से किस टॉपिक को थीम मान के, दीज आर द थीम, तो इसके बेस इस थीम पे आप बना सकते हैं.
ठीक है मैम, थैंक यू।
मैम कैटेगरी 2 के लिए बताना एक बार.
सेम है बच्चे, सेम ब्रॉड एरियाज थीम्स हैं हमारे. क्लीन एंड ग्रीन एनर्जी, फूड सेफ्टी, हेल्थ एंड मेडिसिन, सस्टेनेबल एनवायरनमेंट, एनर्जी हार्वेस्टिंग, स्टोरेज, सेम टॉपिक्स.
मैम कंपटीशन मैम लेक्चर के बाद स्टार्ट होएगा?
हाँ, कंपटीशन लेक्चर के बाद स्टार्ट होगा. उससे पहले फर्स्ट यू हैव टू शो योर ब्लैंक्स शीट्स. ऐसा ना हो कि पहले बनाया हुआ है, हम अगर हमें ऐसा लगा तो हम लोग उसे कंपटीशन से बाहर कर देंगे. एवरीथिंग, द स्केच एंड एवरीथिंग हमने आपको पहले ही टाइम बहुत दिया हुआ है सो दैट यू कैन हैव योर प्रैक्टिस एंड एनीथिंग. हाँ, तो अभी आप लोग वहां पे ब्लैंक शीट्स के साथ बैठेंगे और वहीं पर ही अपना ड्रॉ करना शुरू करेंगे. वी आर गिविंग यू इनफ टाइम, 1.5 hour. ठीक है, देन आपको एक गूगल फॉर्म मिलेगा फॉर सबमिशन, तो उसमें आप करेंगे. इन बिटवीन वी कैन जस्ट हैव डिस्कशन विद यू कि क्या आप काम कर रहे हैं, किस टॉपिक पे कर रहे हैं. यस मनरूप प्लीज. मनरूप कौर, आपका हैंड रेज है बेटा. और एक चीज और इम्पोर्टेंट आप लोग ध्यान कीजिएगा, while listening the lecture, if you have any query, just raise your hand for that. हम आपको बोलेंगे कि आप क्वेश्चन पूछ सकते हैं एंड वी विल ट्राई कि आप एंड में क्वेश्चन पूछें. ठीक है, इन बिटवीन किसी की तरफ से कोई भी विंडो से आवाज नहीं आनी चाहिए. सो कीप दैट इन माइंड. ठीक है, हमें कोई भी न्यूसेंस और नॉइस नहीं चाहिए ड्यूरिंग द लेक्चर. तो इट शुड नॉट बी डन कि भाई हमारा माइक ऑन रह गया था. इट इज योर रिस्पॉन्सिबिलिटी टू टेक केयर ऑफ योर माइक्स. अगर आपको इन बिटवीन, हाँ सृष्टि एक सेकेंड, अगर आपको कोई क्वेश्चन पूछना भी है तो आप चैट बॉक्स में लिख दीजिएगा. अदर टू जस्ट इमीडिएट एकदम से एक्साइट होकर माइक ऑन कर दे, उससे बहुत डिस्टरबेंस। कई बार क्या होता है माइक ऑन हो जाता है और रहता है, बैकग्राउंड में से आवाज आती रहती है। तो अगर आपको इन बिटवीन कोई क्वेश्चन पूछना है तो यस यू कैन राइट ऑन अ चैट बॉक्स, इट विल बी डिस्प्लेड एट आवर साइड और फिर क्वेश्चन रेज भी कर देंगे। यस सृष्टि बोलो। सृष्टि आप कुछ कह रहे थे बेटा?
Yes, ma'am. But I wanted to ask that the information about our name, class, and all that we need to write it on our sheet only, or we need to attach it with it.
You can write on the back side of the sheet if you're not having the proper space. Means if you are not using the larger sheet and small sheets you are using, so you can write on the back side. And later during the Google form, you will find the kind of columns to fill that. Your name, class, category, like school name, the theme and the title, everything you will find on your Google.
Okay, ma'am. Thank you, ma'am.
Our speaker has joined. Namaskar, sir. Professor
Namaskar,
Sandeep.
sir.
Yeah. Hello. Good morning.
Good morning, sir. How are
Morning,
you,
sir.
sir?
Morning, sir.
So we can start after 15 minutes.
Yes, sir.
So I will exit right now. So this I just wanted to check it. So I will.
Okay, sure, sir. Sure. We'll
I
start
will
sharp
join
at 11. Yeah.
Yeah, I will join at 10:55.
Okay, sure, sir.
Yeah.
नीरा मैम नमस्कार। मैंने देखा नहीं था उस टाइम में। आई वाज इंटरेक्टिंग विद स्टूडेंट्स।
हाँ नहीं आई वाज व्हेन यू वर गिविंग इंस्ट्रक्शंस तब मैंने ज्वाइन किया हुआ था।
तो स्टूडेंट्स अभी कुछ क्वेरीज हैं तो यू कैन आस्क। वी आर हैविंग जस्ट 5 to 7 minutes before starting of the lectures, so we can discuss any of the query related to that poster making competition. So any small doubt you can ask right now.
मैम फोन का यूज तो कर सकते हैं ना बनाने के लिए?
फोन का यूज कैसे बेटा? देख
मैम कुछ ड्रॉ
वैसे देखना तो नहीं चाहिए।
It should not be allowed.
हाँ वो नहीं, अगर हमें ऐसा लगा नहीं, आप लोग पहले अगर आपको अभी आपको पता चल गया नहीं, आप पहले अपने दिमाग में एक पिक्चर आउट बना लीजिए। अदरवाइज नहीं, इट शुड नॉट बी। अदरवाइज व्हाट इज द मीनिंग ऑफ द कंपटीशन? सम पीपल आर वेरी गुड इन। हमें क्या चाहिए? आपकी क्रिएटिविटी भी चाहिए उसमें, कि आप उस थीम से रिलेटेड आप क्या थॉट में रख रहे हैं। ठीक है।
एक्सक्यूज मैम।
यस मुस्कान।
मैम जो 10 मिनट डिस्क्रिप्शन है वो हमें तभी साथ साथ देना होगा?
In between we can also ask, or if judge panel required to ask you separately, they can ask.
Okay, ma'am.
एक्सक्यूज मी मैम।
Yes, Ruchika. Yes, Ruchika.
मैम सेकंड कैटेगरी को कोई अलग से मीटिंग ज्वाइन करनी है या मैम इसी में ही?
आप लोगों को कोई लिंक मिला है? सेकंड कैटेगरी में डॉक्टर पूजा आप लोगों ने लिंक बनाया है?
Students will be provided another link for your competition.
आप लोगों को जो व्हाट्सएप ग्रुप बनाया है उसके ऊपर आपको एक लिंक कैटेगरी वाइज मिल जाएगा। ठीक है।
मिल जाएगा, उसमें ज्वाइन करना। कुछ फर्स्ट
Okay, ma'am.
कैटेगरी, कुछ फर्स्ट कैटेगरी के लिए।
एक्सक्यूज मी मैम,
यस यस प्रवीण।
मैम फर्स्ट कैटेगरी के लिए यही लिंक है क्या, कोई और मिलेगा?
नहीं, आपको सब जो भी, अगर यही लिंक कंटिन्यू रहा तो भी आपको इन्फॉर्मेशन व्हाट्सएप ग्रुप पे मिल जाएगी, सेपरेट लिंक हुआ वो भी आपको मिल जाएगा।
थैंक यू मैम।
पूजा मैम, अगर कोई और इंस्ट्रक्शन रह गई हैं तो प्लीज यू कैन कन्वे एंड
नहीं मैम, इट्स ऑल फाइन।
ओके।
Excuse me, ma'am.
यस हर्षदीप।
मैम ये यूजी कैटेगरी के लिए है।
ये अभी सभी के लिए बच्चे, दिस प्लेटफॉर्म राइट नाउ वी आर ओपनिंग इज फॉर एवरीवन फॉर द लेक्चर। Before commencing this poster competition, we have one expert lecture. Okay, and this group is for everyone. अगर कोई और इस पे नहीं है तो we are also having our YouTube link, तो आप उस पे भी ज्वाइन कर सकते हैं। आप लोगों के पास अगर किसी और ने भी लेक्चर सुनना है, they can also join the lecture via YouTube.
Okay, ma'am. Thank you.
एक्सक्यूज मी मैम।
Yes, yes, आशीष।
मैम हम टाइटल चूज कर लेना, मतलब अपने हिसाब से।
हाँ, टाइटल अभी आप चूज कर लो, बट ऐसा ना हो कि आप स्क्रीन से कुछ देख के बना रहे। अगर हमें कोई, मतलब इस तरीके से हमें दिखना चाहिए कि इट इज बीइंग यूनिक फ्रॉम योर साइड।
ओके मैम।
आपको चैट बॉक्स में एक लिंक मिला होगा, वो यूट्यूब लिंक है टू ज्वाइन द सिमिलर लेक्चर। ये संजय, आपका हैंड रेज है बेटा।
Excuse me, ma'am. Can we start?
Vaibhav, I'm just waiting for our speaker to join, then we will start. Huh?
एक्सक्यूज मी मैम
हम्म,
मैम हमें वीडियो जो हम ड्रॉ कर रहे हैं उसकी दिखानी है
हाँ बेटा, उधर कैमरा फोकस करना है आपने।
मैम अगर हम लैपटॉप में लगा रहे हैं तो नीचे का तो शो नहीं होता, सिर्फ फेस दिखते हैं।
हाँ, तो आप अपने आगे कोई छोटा टेबल वगैरह रख के नहीं कर सकते हैं? ऐसा कुछ पॉसिबल है?
ओके मैम।
ट्राई कर लो। अगर या आपसे जब बोला जाए तो एक बार आपको दिखा लेना।
ओके मैम, ऐसा कर लेंगे।
हम स्टार्ट कब करना है?
बच्चे, आपको पोस्टर मेकिंग कंपटीशन आपको गूगल लिंक मिलेगा, ठीक है, कैटेगरी वाइज, वो आपको तब स्टार्ट करना है। अभी वी आर हियर फॉर लिसनिंग द लेक्चर, ठीक है। तो एक लेक्चर अभी होने वाला है, 1 घंटे का वो लेक्चर रहेगा, and you'll find the lecture will be very motivating, very interesting and very dynamic, so be there for that. फिर एक आपको in between instructions मिल जाएंगी when you have to start. Okay?
ओके मैम। ओके मैम।
लीरा मैम।
हाँ जी मैम। हाँ बोलो डॉक्टर सुमन।
हाँ मैम, संदीप सर has joined again. Shall we start now?
हाँ नमस्कार डॉक्टर साहब, कैसे हैं?
हेलो, गुड मॉर्निंग मैडम। ठीक हो? हाँ जी
जी ठीक है। हाँ प्लीज प्रोसीड।
हाँ जी।
हाँ सुमन प्लीज प्रोसीड।
Yeah, okay. Yeah. Good morning, sir, and good morning, everyone, one and all present here. I, Dr. Suman Mehindia, Associate Professor from the Department of Physics, Kurukshetra University. On behalf of this firm and Kurukshetra University itself, take this opportunity to formally welcome you all for the day 2 of the Science Carnival 2022. So after the successful event of the day 1, in which we had the one motivating lecture from Professor S.K. Mehta, Vice Chancellor of Ladakh University, followed by the science quiz competition, we are now entering to the day 2 of this. And for today, we are having one lecture from the Professor Sandeep H. Pal from the Department of Physics, Punjab University, Chandigarh, and he'll be talking about space science and technology. Obviously, this topic is grabbing the interest of the listener itself. And now it's my formal duty to introduce you about or to give you the brief introduction about this forum. This forum is basically the Women in STEM Forum, KUK, and it was established in 2019. This forum was constituted with the frame of background to empower the women faculty of science, engineering, technology, life sciences, mathematics to carry their career and research without any hurdles. So further to foster their research career further on. So this form also guides them about available opportunities for their future endeavor. Further, this also provide a platform to identify the hurdles faced by the women in building their career. So we also promote the girl student from the school UG and PG courses and increase their scientific development to carry their career in various streams of STEM through the group discussion or through interaction by organizing a workshop and lecture series, etc. So we right now we had completed 2 sessions for this forum, and we are just leaving in the third session under the coordinatorship of Professor Meera Radha, chairperson of the chemistry department. And we are 9 members right now. Professor coordinator, Dr. Sunita Dalal from the biotech department, Dr. Abdullah from the UIT chemistry department, Dr. from the electronic science department, Dr. Pooja from environmental studies, and Dr. Anju from Institute of Pharmaceutical Sciences, Dr. Suresh from the Department of Chemistry, and Dr. Hardeep Rai Sharma from the Department of Environmental Sciences. So we are having the committee including almost all the streams of the STEAM. So before just starting the lecture from the Professor Sandeep, it's my formal duty to introduce you, sir, about the sir to all the participants and the guests present here. So first of all, I would like to thank you, sir, to accept our invitation on a single note. So Professor Sandeep Sahijpal did his MSc honors in physics from Punjab University and PhD also from the Punjab University. PhD from the Physical Research Laboratory, ISRO, Ahmedabad. He was a visiting scientist at University of California, Los Angeles, US, before joining PU as a faculty member. His field of specialization is astrophysics and planetary science. He do research in the origin and evolution of our galaxies and the solar system. He is interested in knowing the cause that triggered the formation of solar system and led to the formation and early evolution of the sun and planetary system. We have developed indigenous numerical codes to understand the formation and evolution of galaxy, the moon, planets like Mercury, Mars, protoplanetary Earth, of Earth and Venus. He has published around 100 research papers in Journal of International and National Repute and also in some conferences. These include the prestigious international science journal like Nature, Astrophysical Journal Letter, MNRAS. He has joined he has been associated with research funding from Planetary Exploration Program of ISRO. And wonder things about the sir is that he is operating the astronomical telescope at the roof of the Department of Physics, Punjab University. Dear participants and guests, I must say you will be definitely enjoy and feel enthusiasm while listening to sir. He is so dynamic. His expertise and experience in the field of space science and astrophysics will definitely launch your thoughts towards the science and the space technology. So with these words, I welcome you, sir, again, and will give you the platform to start the lecture further on. Over to you, sir.
Okay, thank you, madam. So I will share my screen. Please
Yes,
let
sir,
me know
sure.
if it is visible.
Yes, sir, sure. The screen is visible.
Okay, and I will share my presentation now. Is it visible?
Yes, sir. Sir, it is visible, sir. There is a one. Yes, okay. You can just press a hide. on this toolbar. This is, yes. Just press the hide section of that.
Okay, I'll keep it here. Okay, so is my voice or I'm audible now properly?
Yes, sir. You are perfectly audible. Your screen is perfectly.
Okay, so I will start my lecture.
Process.
Okay, so this is going to be some sort of a scientific as well as a motivational lecture, especially for the youngsters. Okay, so I'm going to talk about space sciences and technology. I will give you a basic overview about this particular field. It's a very vast field. In case some of you are interested in pursuing space sciences or technology, you can think about it. Okay. In fact, in India, we have Indian Space Research Organization, which is the basic agency, government agency, which handles the space science and technology. Okay. Okay. So let me first of all give you a basic overview about this particular field. This is a very vast field. Okay. It covers astronomy, it covers astrophysics, planetary sciences, atmospheric sciences, climatic studies, weather forecast, telecommunication satellites, remote sensing, defense and security of nation. So you can see that it's a very elaborate subject. In fact, if you are doing space sciences and technology, you are actually working on one of these fields. Okay. It's a list of fields actually. So that is why I said that it could be a motivational lecture for some of the youngsters because there are so many fields here. Okay. Now I will give you a basic overview about these various fields. Then depending upon your interest, you can pursue your career in one of them. Okay. Again, I repeat this thing. Then in India, Indian Space Research Organization, which we call as ISRO, that is the basic nodal agency which handles space sciences and technology. You can visit their website. They have got several research institutes in India. You can apply there after MSc, okay, or maybe after BSc. If you are from an engineering background, you can again apply there. Okay, so there are a wide range of approaches which you can follow. But at the end of everything, you will be working at the most in two of these fields. Okay, there are things which are related with pure sciences. Okay, these are basically the pure sciences subjects, and these are application based subjects. For instance, launching a spacecraft, launching a satellite. The satellite could be a telecommunication satellite, it could be a remote sensing satellite, it could be a spy satellite, depends upon the nature of the satellite. So these satellites are made in India, and these are launched by vehicles which are basically rockets, by Indian rockets. Okay, so I will give you a basic overview of all these things. So let me first of all start with astronomy. Now, what is astronomy? In astronomy, what we do is that the traditional approach is that you take a telescope, a very powerful telescope, okay, and then you watch the sky, you watch the universe. So astronomy is basically an observational science by which we observe the universe. Okay, so we observe the nebula. Okay, now what are these nebulas? These are very big clouds of gases. In some of these clouds of gases, stars are born. They take their birth. Okay, so the stars, they follow a journey. They are born, they live for some time, then they die. And during their lifetime, what they do is that they burn fuel. For instance, in our sun right now, the sun is converting hydrogen into helium in its core. Deep inside the core of sun, there is a fusion reaction, a nuclear fusion reaction, which is going on, which is converting hydrogen to helium. That is how the sun produces energy, and which we are receiving. And the life on our planet is because of sun, right? Majority of the stars that you see in the sky, in those stars, the basic conversion of hydrogen to helium takes place. at the core of the star, and that is what makes the star shine. Now in astronomy, what we do is that we observe stars. Okay, like for instance, this one, you have galaxy. This is an entire galaxy. A typical galaxy can have hundreds of billions of stars. 1 billion is 10 to the power 9. You write 1, then you write 9 zeros. So imagine that you have 1 followed by 10, by 11 or 12 stars, zeros. Okay, this many stars, hundreds of billions of stars. So in astronomy, we observe stars, we observe galaxies, we observe regions which we call as the star forming regions. We observe nebulas. Okay, you see all these photographs. Okay, beautiful photographs. So astronomy is an observational science. And how do we observe it? We use telescopes. Most of you have some idea that we have an electromagnetic spectrum. In the electromagnetic spectra, we have gamma rays, X-rays, ultraviolet rays, visible rays, infrared, then we have radio waves. So we have a wide range of wave frequencies. Now we have got wide range of telescopes which cover all this entire electromagnetic spectra. So we have ultraviolet telescopes, infrared telescope, radio wave telescopes. These different wavelengths give us different information. So in the present day era, we not only use the visible telescope, but we use wide range of telescopes in the entire electromagnetic spectra. Am I audible? Na? Can somebody tell me? Hello?
Yes, sir.
Yes, sir. Yes, sir.
कोई अपना नाम बता दो, बच्चे कोई अपना नाम बता दो जरा मेरे को. रुद्र.
भवेश.
हाँ, रुद्र मेरे को ना 5 मिनट बाद ना बताते रहना कि एवरीथिंग इज ऑलराइट. ठीक है, अपने आप बोलते रहना, क्योंकि हम कम्युनिकेशन नहीं ना, अदरवाइज मेरे को पता लगेगा. अपने आप ये बोल देना ठीक है सब कुछ. ठीक है रुद्र, ध्यान रखना. ठीक है.
Yes, sir.
Okay, so in astronomy, we basically use wide range of telescopes and we observe the universe. Okay, and universe is a very, very big place. You just imagine that we are a very tiny part of our universe. We live on a planet Earth. In our solar system, there are 8 planets. It's a huge solar system. Then our solar system is a part of Milky Way galaxy, which has got something like 300 or 400 billion stars. Then there are trillions of galaxies in our universe. Okay, so we start with trillions of galaxies in our universe, and every galaxy has got hundreds of billions of stars, and every star can have planetary system, and we happens to be on one of the planets of our solar system. Okay, so it's a very vast region of space. Now, what is astrophysics? Astronomy, I told you that it is an observational science. Okay, we observe our universe with a wide range of telescopes across the entire electromagnetic spectra. Okay, in astrophysics, what do we do? In astrophysics, we develop theoretical models. Okay, now what is that? See, there is a basic quest that comes in our mind. How did this entire universe came into existence? Means, how did Big Bang occurred? Okay, how did galaxies form? How were the stars formed in the galaxies? How was our solar system formed? How was our sun formed? How the planet Earth was formed? How the moon was formed? How the life originated on Earth? What is so great about Earth? Okay, there are thousands of questions which comes to our mind regarding the origin of our universe. Okay, we basically want to understand how this entire thing came into existence. So in astrophysics, we develop models. Okay, based on the astronomical observations, we develop models. रुद्र ठीक है ना? रुद्र, हेलो.
Yes, sir. Everything is okay.
हाँ ठीक है, बोलता रहो रुद्र मेरे को 5-5 मिनट बाद. ठीक है. Okay, so in astrophysics we develop models. मॉडल अब क्या होता है? मॉडल्स आर बेसिकली theoretical machinery based on which we try to understand the origin or evolution of a particular thing in our universe. For instance, how did Earth form? How did Sun form? Okay, so you will have a theoretical model which will explain us how this, what is the chemistry behind it. In case you are talking about life, then what is the biology or chemistry associated with it. For instance, Earth is the only planet in our solar system where we know that life definitely exists because it's there. You see it all around you. Now, what is so great about Earth? Earth has got liquid water, and liquid water is one of the most important ingredient of life. You cannot have life without liquid water. Okay, so that is why we have life on Earth. Can we have life on other planets or other satellites in our solar system? Answer is that we can have. Do we know that it exists? Answer is right now we have no evidence. But then in future, we may come to know about it. Okay. So in astrophysics, based on whatever we acquire information from astronomy, observational science, we develop theoretical models. So astrophysics deals with that. It will handle all the queries that will come to your mind regarding the origin, evolution. How did this entire thing came into existence? Okay, we do that thing. It's not something, we have an explanation for everything, almost everything that you can think about. Then there is an important component of space sciences, and that is planetary sciences. Okay, so in planetary sciences, let me first of all do the astrophysics part. Based on whatever we have acquired knowledge from astrophysics, okay,
Yes, sir.
we think that our universe originated around 13.7 billion years back. Okay, 13.7 billion years back, our universe originated, and it originated from what we call as a Big Bang. So it so happens that 13.7 billion. Now, what is 1 billion? Billion is 10 raised to the power 9. So 10 raised to the power 9 years. Okay, 13.7 into 10 raised to the power 9 years. What was there before that? The answer is there was nothing there. Literally nothing. There was no space, no time, no matter, no energy, nothing, no star, nothing was there. So a Big Bang occurred. Now, how did it occur? Now, in quantum mechanics, there is a possibility that even if nothing is there, something can come out of nothing. And our universe is an example of that. So when our universe was created, the space, time, matter, energy, everything came into existence. And that happened 13.7 billion years back. Now, the question is that when our universe it got originated, did it have everything like stars, planets, and everything? Answer is no. It started with the most fundamental thing, which is what we call as the quarks and the gluons. Now, the quarks and the gluons are the fundamental particles which make our universe. You know about protons and neutrons. Now, if I start digging inside what is there inside the proton and the neutron, I will end up in quarks and gluons. Okay, so our universe started with the quark and gluon plasma. So there was everywhere quark and gluon plasma. This Big Bang was having very high energy, and as the universe started expanding, it started creating its own space and time. It started expanding. So the average temperature of the universe started going down. So the first thing which happened was that all the protons were created inside the universe. Protons along with the neutrons were created. Then there was an era in which all the electrons that we have in our universe, it got created. Okay, so our universe started evolving in such a manner that it will have only the protons and the electrons and the neutrons in the beginning. After that, as the universe continued to expand, the protons and the electrons combined to produce hydrogen atom. A little bit of helium atom was also produced, 75%. The rest of everything, you know the periodic table, from carbon to uranium, nothing was produced after the Big Bang. Okay? Only the protons and the helium were produced. Then the first thing which happened was that the galaxies started forming. Because once you have hydrogen gas, the hydrogen gas will form some very big clouds. Now, we are not talking about the atmospheric cloud. These are very big clouds. So very big clouds were formed. This is the beginning of the formation of galaxies. Now, inside the galaxies, these gases, hydrogen and helium gases, what they will do is that wherever their density of these gases are very high, they will come together, the gravity will bring that matter together, and it will result in the formation of stars. So that is how the first generation stars were formed in our universe. Okay, so how does the star formation takes place? Huge amount of gas, mostly hydrogen, it is squeezed by the gravity squeezes it, and it results in the formation of a star. And when do you say that a star is born? When at the center of this star, the hydrogen starts burning into helium through the nuclear fusion reaction. Okay, this makes the star shine. So basically, at the core of the star, the hydrogen gets converted into helium. Okay. Afterwards, what happens is that there are other nuclear reactions which takes place. What can happen is that the helium nuclei can fuse to produce carbon. The carbon can fuse to produce oxygen or magnesium or higher elements. So this way, all the elements up to iron are produced by nuclear fusion reactions and some other reactions. The rest of everything beyond iron up to uranium lead, all of these things are produced inside stars by a wide range of nuclear reactions. There are thousands of nuclear reactions which take place inside the stars, and all the elements are produced. So if you ever wondered how all the elements in the periodic table were formed in the first place, so this is how they are produced. So basically, stars are nuclear factories where all the elements are produced. Then what happens is that once the stars evolve, they die. Okay. So at the end of their life, when they die, they throw their material in the form of supernova or in the form of red giant stars. They throw their material into the space, interstellar space. From this material, another generation of stars are born. Then the same cycle repeats. Again, these stars will produce elements. Then they will die out. They will throw their matter into the space. Then this cycle keeps on going on. Okay. Something interesting happened around 4.5 billion years back. Okay, please keep this thing. Big Bang occurred 13.7 billion years back. The solar system formation occurred 4.5 billion years back. Okay, at that point, our sun and our planets were formed. So you can see that the formation of our planetary system, which means the sun and the planets, it occurred recently, only 4.5 billion years back. Whereas the Big Bang occurred 13.7 billion years back. It's a very old thing. Of course, you know that now that the stars produce all the elements. And in our solar system, we have got all the elements. You see that this Z equal to 1.4%. The Z contains everything from carbon to uranium. Okay. Here it was Z was 0 at the time of Big Bang. How did Z evolve to 1.4? Because elements were produced inside the stars. So the important thing is that if you ever wondered how you got iron in your blood, you got calcium in your bones, you got carbon around you, wherever you see carbon, oxygen, nitrogen, gold, silver, platinum, name any element. If you ever wonder where was it produced, the answer is that these elements were produced by nuclear reactions inside the stars before the formation of the solar system. Okay, so before the solar system was formed, all these elements were produced inside the stars. And when our solar system formed, all these elements were brought inside the solar system. Okay, our Earth has got all these elements. So this explains how the Earth contains all these elements, which we have in the periodic table. रुद्रा ठीक है ना? रुद्र प्रताप, हेलो.
Yes, sir.
नहीं बोलते रहो, मेरे को बोल दिया करो, ठीक है?
Yes, sir. Okay.
Okay. So in astrophysics, we basically address all these issues related with the origin and the evolution of our universe. Those of you who have interest in this particular thing, they can pursue your interest according to your need and according to your caliber. Okay. Then we have a branch of science which we call as a planetary sciences. Now, what do we do in planetary sciences? We have Sun, the main thing in our planetary system. Then we have Mercury, we have Venus, we have Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. And then we have asteroids, thousands of asteroids going around the sun. We have comets. And then we have moon. Earth has got moon. Jupiter has got something like 70 satellites. Saturn has got 70 satellites, more than 70 satellites. Okay. So this is our solar system. Now there are two aspects related with planetary sciences. One is what we call as the pure sciences, and the other is what you can call as the applied sciences. In the pure sciences, what we do is that we try to understand how these planets were formed. Okay, why Mercury, Venus, Earth, Mars are rocky planets. See, the interesting thing is that these inner planets like Mercury, Venus, Earth, Mars, these are rocky planets. You can stand on the surface of these planets. Whereas the outer planets like Jupiter, Saturn, Uranus, Neptune, these are gaseous planets. They have got lot of gas, hydrogen gas. Okay, so you cannot stand on the surface of Jupiter, Saturn because it's gaseous. If you want to stand, you have to go deep inside. Okay. Now, there is a basic question: why inner planets are rocky and the outer planets are gaseous? Okay, this is one question. The next question is why the outer planets are giants. So it has to do with the formation of our solar system. Okay, the way the solar system formed. It so happened that when our solar system was forming in the inner solar system, rocks could form, rocky contents could form. Okay, whereas in the outer solar system, not only the rocks could form, the ice could also condense because the temperatures were low there in the outer solar system. Okay, so the basic thing is that in pure sciences, we would like to know how these planets were formed. Okay, why Jupiter and Saturn have got 70 satellites, more than 70 satellites. Okay, is there possibility that we have life anywhere in our solar system? Earth, we know it has got liquid water, so it has got life, right? There are satellites of Jupiter and Saturn where we have liquid water. So there is a possibility that some form of life could exist there. Are we sure that it exists? Answer is we do not know right now because we do not have any evidence. In future, when we are sending more spacecrafts, we will know about it. Okay. So there are hundreds of problems related with planetary sciences where we try to understand how the planets were formed, how these planets evolved. This is what we do in pure sciences. There is an applied science part. Now, what is that applied science part? On our planet Earth, life originated some 4 billion years back. 4 billion years. Okay, 4 billion years back, life originated. Then it started evolving. Okay, Homo sapien, which we are. Okay, we evolved in the last 2 million years. Okay, so our evolution is just confined to the last 2 million years. We evolved from apes. Okay, and we evolved from apes somewhere in Africa. Then we started migrating. Our ancestors started migrating. Some of them came to India, some of them went to Europe, some of them went to China, then America. So that is how it went. Now the basic question is that this human migration, has it stopped? The answer is no. So far, we have captured the entire planet Earth. There is not a single place on our planet Earth where you don't see human beings. Are we going to go beyond that? The answer is yes. Now we are going to go beyond that. How is that possible? It is possible through space technology. If we have rockets, powerful rockets, we can go to maybe Mars, we can go to Venus, Mercury, we can go to the satellites of Jupiter, Saturn, and of course our moon. What can we do? We can also go to asteroids. In future, there is a possibility that maybe in the next 100 to 1,000 years, we will have colonies on moon, we will have colonies on Mars, we will start doing mining on asteroids. Okay, this is a very important thing. You can extract mineral resources from asteroids, from moon, from Mars. Okay, so just like our ancestors moved out of Africa and started settling everywhere on our planet Earth, our future generations, they will move everywhere in our solar system. Okay, so in thousands of years, human beings will be living almost everywhere in the solar system. This is our future. Okay, so here you can understand that how important is space technology in this aspect. So one component is that you will start living in those places, of course, your future generations. The other aspect is that you can start digging up those places for extracting the mineral resources. Okay, so we have plenty of mineral resources in our solar system. So there is enough for everybody. Rudra, theek hai na? Rudra?
Yes, sir.
Okay. So we have wide range of things. So for instance, this is Jupiter. This is one of the satellites of Jupiter. Its name is Io. In future, imagine that there is a space station somewhere here. Okay, one of your offspring, maybe after 10th generation or 20th generation, they are living in that spacecraft and they can visit this Io from space. Okay, Io has got most active volcanoes in our solar system. So if you want to see very beautiful volcanoes, this is the best place. So if your future generation somewhere wants to visit for a vacation, they want to see very big volcanoes, they can go there. This is space tourism. Okay, just a way of I'm just telling you the things just to create some excitement. This is Saturn. You can see the ring of Saturn.
Yes, sir.
This is one satellite of Saturn. Its name is Enceladus. It has got lot of water. So the water erupts in the form of geysers. Okay, so you have plenty of water. No problem as far as the liquid water is concerned. The satellites of Jupiter and Saturn have got lot of water. This is the ring of the Saturn. You can see the detailed structure of the ring of the Saturn. It is actually made of very big boulders of ice, very big chunks of ice, thousands of them, millions of them, which are going around Saturn. So what you see as a ring of this Saturn is actually the boulders of this ice which is going around the Saturn. There is one very interesting satellite of the Saturn. Its name is Titan. Okay, this is the biggest satellite of Saturn. This is an artistic image. You can see Saturn if you are standing on Titan. Okay, in fact, there was a Cassini-Huygens mission which was sent by America. The Huygens probe actually landed on Titan. Interesting thing about Titan is that if you see its atmosphere, it is rich in hydrocarbons. Now, wherever you have hydrocarbons, there is a possibility that you can have life. So scientists are speculating that there is a possibility of life on Saturn. There is one very interesting thing about the planetary sciences, even astrophysics. If you want to approach astrophysics and planetary sciences as a physicist, you can do it, because you will be understanding you will be basically dealing with the origin and evolution of things. If you want to approach this field as a chemist with the chemistry background, there is a lot of chemistry which is going on in these satellites and planets. Okay, in fact, you cannot do that chemistry in your lab. Okay, if you are a biologist, again, there is an approach. If you want to understand how the life originates, how it evolves. So this is the classic example of Titan. On Titan, we think that there is methane-based life, CH4. We have methane-based life on Titan. There is a possibility. It's not sure. The methane is in the liquid state on Titan. Okay, there are lakes and rivers of methane, liquid methane on Titan, and there is a possibility that you can have life based on methane on Titan. It is not confirmed yet, but then people are speculating. Okay, in planetary sciences, when we are trying to do the things, what we do is that there is a concept which I'm going to talk about even in future, and that is what you call as a remote sensing. See, what you do is that, for instance, in this particular case, this is Mars, the planet Mars, our nearest planet. So when you send a spacecraft to that planet, it goes in the orbit of that planet. It's an orbiter. It will keep on going around it. So on that spacecraft, you have wide range of cameras, you have spectrometers in different wavelengths. So you take photographs or you do the spectroscopy. For instance, here it is the altitude. You can see the altitude. The white thing represents the high peak. For example, you can see the peaks here. Okay. There are 3 prominent peaks on mountains on Saturn, 4. Okay, one of them is Olympus Mons, Olympus Mountain. This Olympus Mons is 27 kilometers high. Okay, imagine that. It is one of the biggest mountain in our solar system. Our Mount Everest is only 8-9 kilometers. If I don't have the exact number, but it's somewhere 8 kilometers altitude wise, Mount Everest.
Yes,
This fellow is 27 kilometers. Okay. On Mars, we can see a very big crack. It's a canyon. It's even bigger than the Grand Canyon in America. Okay. There are depressions, there are low-lying areas, there are high-lying areas. Now, when we study Mars, there is something interesting which appears. And that interesting thing is that in past, long time in past, Mars was having liquid water. Okay. There were rivers, there were lakes on Mars. Okay. All that water evaporated. Okay. Now, there is an interesting thing that Mars was having magnetic field in the earlier past. Okay. There was a collision, a planet came and it collided. A very small planet came, it collided with Mars. Mars lost its magnetic field. Okay, it was gone. Because there was no magnetic field on Mars, the entire atmosphere of the Mars, it escaped. You know the escape velocity concepts, all those things. As a result of which, the atmospheric pressure on Mars, it went down. Okay, it went so down that the water evaporated. See, on our planet Earth, liquid water exists because we have atmospheric pressure. You release that atmospheric pressure, the water will evaporate, even at room temperature. Okay, and it will go away. The poor fellow Mars, it has gone through that problem. The entire water evaporated from it. Some of it is left in the form of ice, but most of it was lost. Okay, so there are wide range of interesting things which you come across when you are studying planetary sciences. The next aspect is the atmospheric sciences, and clubbed with it is the climatic study. Now, what do we do here? In the atmospheric studies, we try to understand our atmosphere. We have a planet Earth. It is surrounded by a blanket of airs. Okay. Now, that is what you call as an atmosphere. Now, atmospheric sciences is a very elaborate field. In fact, in India, most of the universities and the institutes which are working on atmospheric sciences, these are in South India. In North India, there are very few institutes associated with atmospheric sciences. So you should keep this thing in mind that if you want to work in this particular field, you have to go somewhere in South, in some university or some research institute. ISRO, look into the ISRO website. So in atmospheric sciences, we try to understand how the atmosphere evolved and what is the structure of the atmosphere. Now in this diagram, we have represented the evolution of Earth's atmosphere. So this is the present position. In the present time, nitrogen is something like 78%. You can see this thing, 78% nitrogen, and the rest of oxygen, 21%, and few other gases. So this is the present composition. Now, what was the composition at the time of formation of this Earth? Our Earth formed 4.56 billion years back. 4.6 billion years back. In the early Earth, atmosphere was rich in ammonia, methane, water vapor, and carbon dioxide. There was a lot of carbon dioxide. And as the atmosphere started evolving, this carbon dioxide, when the life originated on our planet Earth, the life started consuming the carbon dioxide. The earliest form life was actually carbon dioxide consuming life. What could be that form? It is either plants, and you have trees, and there is another thing which we call as the cyanobacteria. Now, this carbon dioxide based life, what it did was that it consumed the carbon dioxide of the atmosphere and it converted it into oxygen. Now, this is the reaction. Carbon dioxide, water will converted into glucose plus oxygen. Where will it take place? It will take place inside the trees, plants, and the cyanobacteria. So, when the trees, plants, and the cyanobacteria consume carbon dioxide from air, take water from the soil, it converts into glucose and oxygen. Now you see that the oxygen started evolving. As the time evolved towards the present time, the oxygen abundance started going up. And we get this glucose from the trees, from the plants. That is the food source. That is the basic food source. So the plants, what they do is that they convert the carbon dioxide into food and oxygen. So gradually the oxygen abundance of our atmosphere started increasing, the O2 abundance. And the life, O2 based life, which is in the form of animals mostly, you have all the animals, they started appearing. So initially the plant-based life and the cyanobacteria life evolved on our planet Earth, and gradually as the oxygen was produced, the animal life started appearing and it started evolving. And in the present time, we have both the plants and the animals. And what they do, they basically are dependent on each other. In what sense? You can see it very clearly. It's a very simple way of understanding the things. What the plants do is that they take carbon dioxide from air, water from soil, convert it into glucose and oxygen. What do animals do? They eat the glucose, they consume the glucose, and they take the oxygen from the air and they convert it back into carbon dioxide and water. So this way, animals and plants are dependent on each other. Okay, animals, they work, the plants work on this reaction in one direction, the animals do it in the opposite direction. This is what we call as a symbiotic relation, because both of them are dependent on each other. Okay, now something bad happened in the last 100 years or 200 years. In the last 200 years, I've told you that there was a perfect balance of carbon dioxide and oxygen, which our nature has produced. Human beings, they started using fossil fuels. Now, what are these fossil fuels? The fossil fuels are the kerosene, wood, oil, okay, diesel, petrol, and everything. So by burning this fossil fuel, we started generating more carbon dioxide. Okay, see, there was a balance between carbon dioxide and oxygen, which the nature was balancing. But the human beings started producing more carbon dioxide by burning the fossil fuel. So the carbon dioxide content in the last 100 years, it went up in a very sharp manner. As a result of which, the average global temperature, if you see in the last 100 years, you see in the last 100 years, this is the period, it has gone up by almost like 1 degree centigrade. Okay. Why it happened? Because the carbon dioxide is a greenhouse gas. The more the carbon dioxide you have in our Earth's atmosphere, the more would be the warming effect, the heating effect. Now, because of this gradual increase of carbon dioxide in the last 100 years, because we started burning the fossil fuel, the average temperature of the Earth has gone up by 1 degree centigrade everywhere on the planet. This is what we call as the global warming. Now, somebody will say 1 degree is not much, but it is very big. When you talk about the entire planet has been heated up by 1 degree centigrade. What is the consequence of it? The consequence of this is that you have unpredictable weather. Sometimes it becomes very hot, sometimes it becomes very cold, sometimes you have lots of rains. So the weather has become very unpredictable. The size of the cyclones, the intensity of the cyclones, it has gone up. Because of global warming, lots of glaciers, even the icebergs of Antarctica and the North Pole, they have started melting, because of which the average glacier strength has gone down. Okay, so all these aspects we discuss in the atmospheric sciences and climatic studies. And this is just one of the aspects, in fact, which I have covered. But there are so many interesting things associated with it. And one of the other interesting things associated with it is the weather forecast. Now, you might have noticed that in North India, you might have seen even in Kurukshetra, I am telling you about Chandigarh, the last 20 days, almost last 20 days, we could not see the sun except for a few couple of days. But then if you look at the weather forecast 1 week back, there was an indication that at least in this week, we will have sunny days. So the sun has appeared. Now, how do they do that? How do they do the weather forecast? Whether it is going to rain on a particular day, whether it is going to be a sunny on a particular day. there is a very interesting science behind it. And there is a lot of computational physics related with it. Now, what these people do is that, first of all, what is the weather, the temperature, humidity, pressure, okay, cloud cover everywhere on the planet Earth today. Let us see that. Okay. They take that information from the various weather stations, then they have complex equations. Those of you who are from who are in BSc and MSc, they solve complex partial differential equations. There are complex partial differential equations. They solve those equations. What is the input to these equations? The input is the present day weather across the entire planet. They get the result, and the result is for the future. So that is how they do the weather forecasting. Okay, so they solve these equations on supercomputers. They have got very big computers because there is a lot of computational thing involved. Then based on it, they give you the weather forecast. So which you can look into the television, or you can look into the various weather apps. Okay, the weather apps will tell you that, okay, in your particular place, next 2 days will be sunny. Then after that, there would be raining. Okay, it's a very complex thing. But these are partial differential equations dealing with the climate. Okay, this is a very interesting branch of sciences. Though, in case somebody is interested, that fellow can pursue it in. Okay, there is one very important lab even in New Delhi related with the weather forecasting. Okay, so it's a meteorology department basically. This is done by meteorological department. Okay, so they take a lot of information. Okay, so this is as far as these sciences are concerned, the space sciences. Now we will talk about the other aspect, which is related with the technology. So the first aspect is related with the telecommunication satellites. So we have thousands of satellites which are right now going around the planet Earth. These are artificial satellites. Now, why these satellites are put into the Earth orbit? Because you can do telecommunication. Okay, so for instance, imagine that this is planet Earth. I have a radio station here or television station here. So there is a satellite here somewhere in this space. So I send my radio signal there. Okay, then this satellite will receive that radio signal and it will transmit everywhere. Okay, so this way you can cover a very large area. Okay, the simplest example which I can talk about is your dish antenna, the television dish antenna. If you have noticed one thing, majority of the television dish antennas, they are pointing towards the southern sky, the south direction. So there are satellites in space there, okay, mostly on Indian Ocean. The various television stations in India and abroad, they send their signal to this satellite. Then the satellite send it everywhere in a form of a single bundle. The dish antenna which you have in your roofs, okay, they receive this signal and then they do the processing, the electronical processing. Okay, so this is a basic form of the telecommunication satellite. Then there are remote sensing satellites. Like for instance, if you want to know which particular region on Earth has got lot of water, which is good for doing a particular type of agriculture thing, which is good for doing wheat cultivation, rice cultivation. So for that, you have to do remote sensing. So remote sensing is a satellite which you launch. What it does is that it starts grabbing the photographs of the land beneath it. Okay, then you analyze all these photographs. It will give you the basic information. For instance, the Google map, if you look at the Google map, This is the simplest form of a remote sensing satellite. What it is doing is that these satellites will capture the images and it displays you. So you can, in fact, use the Google Maps to go to different places. So all these things come in space technology because you are doing basically working on the satellites. Then there are satellites associated with defense and security of the nation. For instance, you know that there is one Cartosat satellite of India. It was used in some military operations in the recent times. Okay, especially when India launched one particular attack in Pakistan in the recent times. Okay, some 3-4 years back. So what you do with these defense and security satellites, you basically want to see the position of enemy, even in their own country. Where have they put their ammunition? Where have they put their tanks or other rockets? Okay, where have they put that? All those things. So you need a satellite for that. The other aspect is that there are several rivers in India which are coming from our neighboring country. Okay, now how do you watch whether the neighboring country is not doing anything bad to those river supplies? Okay, so you have to keep on watching them. Okay, so all these things are done through satellites. Now, what is a satellite and how does it work? If you have a simple telescope, what we do is that with a simple telescope, we watch our universe. We watch the galaxies, we watch the stars and the planets. If I take this telescope, I put it in a satellite. Okay, this is a solar array of a satellite by which you produce electricity. Okay, so if I put this telescope at the bottom of this, you can take the images of Earth. So when you do astronomy, you sit on the Earth, take a telescope, watch the sky. In all these satellites where you have cameras, okay, you are doing the reverse thing. Reverse thing means that your telescope is in the satellite and you are watching the Earth. Okay, this is what you are doing. For instance, you see this particular, there is a stadium here. It's like a Google image. Okay, so this is how they grab the Google images. They have telescopes and very powerful cameras mounted on the satellites. When the satellite passes through a particular region, it grabs that image. This is one very interesting image of India. You can see our country in night time. This is nighttime image. How do you know it's a nighttime image? You can see the lights. You can see the lights. For instance, this is Delhi. Okay, Chandigarh is somewhere here. Okay, Kurukshetra would be somewhere here. Okay, this is Mumbai. This is Chennai, Bangalore, Hyderabad, Kolkata. So you can clearly see it. Okay. Now, what is interesting about this image is that we don't see lot of light here. Rudra, theek hai na? Rudra Pratap, is it okay?
Yes, sir.
Okay.
Thank you, sir.
We don't see lot of light here. What does it imply? It can imply two things. One is that there are lots of forest over there. If it is forest, it is all right. It is good that we have good forest. But if it is not forest, what could it imply? It could imply that maybe that particular region is not, it is underdeveloped. They don't have electricity. Okay, in the rural area, they don't have electricity. So when people who work on these aspects like human development, what they do is that they use these images. Okay, because based on some such images, you can tell which regions are more developed and which regions are underdeveloped. Okay, of course, I'm not particularly picking up this particular region. The actual reason is that in this particular region we have forests. Okay, Okay, so we don't have other problem here. Okay, so this is one remote sensing image where you can see the night time. Okay, a typical telescope which we have in our university, which I operate. So this is that particular telescope. Okay, what we do is that when we make a spacecraft, okay, whether India is making or some other country is making, what they do is that they mount these type of telescopes on spacecraft. This is how a typical spacecraft will look like. Okay, and in this particular case, this is Voyager. There was a spacecraft which was sent by America long time back. It is Voyager. It has even crossed our solar system. It has gone out of our solar system. So a typical spacecraft will have a dish antenna. This is a dish antenna through which we send the signal to the spacecraft and we receive the signal from the spacecraft. Okay. Then a typical spacecraft will have some cameras which work in infrared, in the visible region. There would be some detectors, cosmic ray detectors. There would be some radio detectors. Okay, so a typical spacecraft will have wide range of instruments, which will include cameras, spectrometers, particle detectors, okay, magnetic field measurement devices. Okay, so wherever this spacecraft goes, it will take the images there, the images of that particular planet or satellite. It will measure the magnetic field. It will measure the particles. How do we get all this data? This entire data is converted into digital signal, electronic signal, and this dish antenna, the radio dish antenna, it sends it towards Earth. And on Earth, we have an exactly similar radio dish antenna. You can see it over here. Okay, the signal is received, it is amplified, and then you get the actual images. So this is how you basically work with a spacecraft. Working with a spacecraft is almost similar to playing with a remote control car. In your childhood, you might have played with a remote control car. In a remote control car, you have a handset, you operate that handset, you have an antenna, the radio waves from that antenna goes, it is received by the car antenna. You remember that there is an antenna on the car toy. That antenna receives the signal and it sends it to the main processor of that car, and then the car works. You want to turn the car towards the left hand side, you do that, you work on the knob and the signal goes there in the form of radio waves. So exactly the same procedure is followed here. Of course, the complication is much more involved here, but as far as the basic underlying principle is concerned, it's almost same. Okay, now this is what I was talking about. We have the entire electromagnetic spectra. We have the gamma rays, X-rays, ultraviolet, visible, infrared, submitter, radio waves. So we have space satellites, we have telescopes in the entire electromagnetic spectra. And in fact, we have spacecrafts in the entire electromagnetic spectra. Okay, so you name any wavelength, we can give you the information of a particular object in that wavelength. For instance, this is our sun. In the visible light, this is how the sun appears. Please never look at the sun directly or indirectly. It can cause permanent blindness. Please don't do that anytime. Okay. We have special ways of monitoring sun. When you look at the sun through in a normal manner, in visible light, this is how the sun appears. But if there is an infrared telescope, this is how the sun could appear. In radio wave, it could look like this. In ultraviolet, it could look like this. This is extreme ultraviolet, this is X-rays. So you name a wavelength, we will have a particular telescope in which, in a particular wavelength, where we can see the things. Generally, what we do is that we actually get information in the entire electromagnetic spectra, and then we start working on the physics. This is another example. There is a galaxy by the name Andromeda galaxy. This is the image of Andromeda in radio waves. This is in infrared, this is in visible, ultraviolet X-ray. Now you see that the images, they change because different wavelengths gives you different information about the same thing. So we grab all these images and we try to extract the science out of it. Now we have, I mentioned earlier, we have thousands of satellites which are going around the Earth, and hundreds of spacecrafts have been sent to other planets. For example, this one is the Mars Finder, which was sent by America. I mentioned about Cassini-Huygens mission. It was sent by America. This particular spacecraft, its main purpose was to study Saturn and its satellite. In fact, the Huygens probe actually landed on Titan. I mentioned about that. There was a Mangalyaan mission sent by ISRO, India. There was a Chandrayaan mission which was sent by ISRO, India. Interesting thing about the Chandrayaan mission was that it discovered water on moon. Of course, the abundance is not very much, but for the first time, water was discovered on moon. Then there is a messenger mission which was sent to Mercury by America. There is a deep impact mission. There is a New Horizon mission which was sent to Pluto by America. This is a very small list. Okay, of course, everything started with Sputnik, the first artificial satellite which was launched by Russia. Now there are hundreds of spacecrafts which have been sent, and some of them are being planned. I told you that all the spacecrafts are controlled through radio communication. So there is a dish antenna on a particular spacecraft. It will send that information, and on Earth, we have a dish antenna here. It receives it. This is an ISRO's dish antenna somewhere near Bengaluru. So it's a dedicated dish antenna to actually monitor the spacecrafts. Okay. So you can send the signal to the spacecraft. You want to turn it in one direction, you want to rotate it. So you will send the signal through this. It will be received by the antenna on the spacecraft. The spacecraft will work accordingly and it will send you the data. Now, how do you launch a spacecraft? This is the Chandrayaan 2. Do is that they put this entire spacecraft in the tip of the rocket. So you can see this entire rocket over here. This is India's GSLV rocket, geosynchronized launch vehicle. Rudra, ठीक चल रहा है ना? Rudra, hello.
Yes, sir. सही है.
Yes, sir.
Okay, so at the tip of this rocket, they put this thing. Okay, now how does the whole thing work? Let us do the basic technology related with it. What is a typical rocket engine? A typical rocket engine will have a liquid fuel. It could be solid, it could be gaseous also. It depends upon the type of a rocket engine. So you need a fuel. You have to burn the fuel. But in space, there is no oxygen. You cannot burn any fuel without oxygen. So you have to carry oxygen. Now, how do you carry oxygen? You carry it in the form of liquid oxygen. Generally, it is called as LOX. Why liquid oxygen? Because if you are carrying it in the form of gas, you need a very big container. It's better to liquefy it and carry it. So you have to cool down this system. Okay, you need a cooling thing. But what you do is that there are pumps in a rocket. You can control those pumps. Mostly it is controlled by computers. You take a particular amount of fuel, you take a particular amount of oxygen, you burn it in the combustion chamber. the most simple fuel which I can talk about is the kerosene oil. You take kerosene oil, take it in the combustion chamber, take oxygen from the liquid oxygen tank, burn it in the combustion chamber. So what will happen? You will have fire. So the hot gases will go out. Okay. Now there is a basic rule in physics that if gases move in this direction, they have a momentum given by mass m and u velocity. The rocket will get a thrust in this direction with a momentum mv because of the conservation of linear momentum. So a typical rocket works basically on the principle of conservation of linear momentum. The hot gases move in one direction, they carry the momentum. The rocket moves in the opposite direction, they carry the momentum. Okay, so this is how the whole thing works. The simplest rocket which you can make is you take a balloon, inflate that balloon, don't tie the end, release it, so the gases will move in this direction. In this case it is cold gases, but anyway, whether it is hot gases or cold gases, the gases move in this direction and the rocket goes in the opposite direction. Okay, so this is the basic principle of a rocket. Now there is a basic thing, I don't want to go into the detail of it. There is a concept of thrust. Thrust is basically mass times acceleration, which is force. Okay, A is the acceleration, m is the mass. A 50 kg person, when he is standing, he exerts a force of 500 Newton on earth. Okay, 500 Newton thrust. A F-16 engine exerts a force of 130 kilonewton, means 10 to the power 3 newtons. A typical rocket engine could go from hundreds to thousands of kilonewton. So this is the thrust which the rocket exerts. And this is how a typical PSLV rocket looks like. Okay, a typical PSLV rocket. There is an interesting thing about ISRO. India actually started making its own satellites long time back, even in 80s, 70s and 80s. Okay, so India became quite competent in making satellites, telecommunication satellites, remote sensing satellite, the INSAT series satellite, right in 70s and 80s. But India was not at that point competent enough to launch these satellites. So we used to go to European Space Agency or American or Russian Space Agency to launch our satellites. But then in 1990s, India developed a system which we call as a PSLV, Polar Satellite Launch Vehicle. This is how it looks like. Okay, this is the actual rocket. It's a very tall rocket. You can see that you can see a door here, small door somewhere here. Okay, a human being would be as big as this railing somewhere here. Okay, it's a huge rocket. So India became quite competent in launching satellites. Now what they do is that they put the satellite or the spacecraft in the tip of the rocket. Okay, a rocket has got several stages. There is a stage number 1. So initially when the takeoff takes place, these engines, the engines which are at the bottom, they burn the fuel. There are details here. Let us not bother about the details. Okay. So the first stage rocket burns. Okay. The first stage rocket starts moving this rocket in this direction. At the moment this rocket acquires a particular height, altitude, this stage becomes redundant because entire fuel within this stage has been burnt. Now there is no point in carrying that stage beyond that. So this stage is detached. It is thrown out. Now only this part of the rocket goes up. Now the second stage starts burning, which is somewhere here. Okay, so the bottom thing is thrown away. So the second stage starts burning. You can see a rocket here, the nozzle of the rocket. The second stage burns, then the fuel within the second stage is exhausted. Then the third stage rocket starts burning. Then the fuel within the third stage is exhausted. Finally, the satellite is launched in this space. Okay, so this is what you call as a multi-stage rocket. There are, in this particular case, there are 4 stages. Okay, this is the India's most efficient rocket system. In fact, India has made several records. In one of the launches, India launched more than 100 satellites together. So all those 100 satellites were kept here, okay, in the tip of the rocket. Okay, so this is how the PSLV system works. Now, ISRO has got range of rockets. This is what I was talking about, PSLV, okay, Polar Satellite Launch Vehicle. There are details here, let us not bother about it. I can say one thing here, that with the PSLV, you can launch a small truck. You can think about a very small truck. You can launch a small truck, or let us say a car in space. But then if you want to launch a very big spacecraft or satellite, PSLV is not good. What do you need then? You need GSLV. Okay, now GSLV is a more powerful rocket. These are the 2 variants of these GSLV rocket. GSLV is Geosynchronized Satellite Launch Vehicle. With this, you can launch a very big truck, which could be something like 4 ton. You can launch a 4-ton object in space. What is so interesting about GSLV is that in this case, the fuel is basically hydrogen gas. Okay, hydrogen gas. You burn the hydrogen with oxygen, you get water. And this reaction is highly exothermic. It produces a lot of energy, and this is what you call as a cryogenic engine. Now, why we call it as a cryogenic engine? Because we are having hydrogen and oxygen. We don't carry hydrogen as hydrogen gas and oxygen as oxygen gas. No, because we will need very big containers for that. So rather than carrying liquid or gaseous or hydrogen and oxygen, liquid hydrogen and liquid oxygen is carried, because you can carry more that way in a small container. Now, in order to liquefy hydrogen and oxygen, you have to cool down the temperature. The temperature should be very low. So that is where you need very cold temperatures. So inside the rocket, you have to maintain very cold temperatures. Then you have to extract a part of this liquid hydrogen, convert it into gaseous hydrogen. Same thing for oxygen, gaseous oxygen, burn them. So this is where the entire cryogenic technology comes. Interesting thing is that India has developed this cryogenic technology, and now India is competent in launching these type of rockets, which are very powerful rockets. Of course, there are small rockets which are required for some experimental thing. So let us not bother about it. The main important thing in India rocketry industry is the PSLV and the GSLV. Okay. If we extend this thing, you can understand that based on the technology which we have for these rockets, you can make the missile systems, whether it is the cruise missiles or whether it's the ballistic missiles. So our entire missile technology is also based on this experience gained through these rockets. Okay, so whether it's the all sorts of missiles which you might have heard about, okay, Agni, Prithvi, and other missiles, is a basic technology remains the same. In the case of the missile, in the payload, this is what you call as the payload, which you put it in the tip. See, here in a rocket, you put a spacecraft or a satellite. In a missile, you put here explosive. Okay, so that is how the whole thing works. Now, I told you about a multi-stage rocket, the PSLV, which has got 4 stages. Now, this is the most powerful rocket system which exists. It's in America. The company is this SpaceX, who is headed by Elon Musk. Okay. Now, this fellow is the mother of all the rockets you can think about. It's a very powerful rocket system. It's a single stage. Okay. It's not a multi-stage, it's a single stage. It has got the central rocket and the 2 side rockets. Now, what it does is this is what makes it very interesting. It has got a very high thrust, 7.6 million newtons, very powerful rocket. It can launch a 20-ton payload. 20 ton is a huge amount. Okay, a typical truck could weigh something like few tons. 20 ton is a very big thing. Now, it is basically meant to launch very big systems into space so that those things are carried to Mars so that you establish colony on Mars. Now, this is a very big game. So if you want to establish a colony on Mars, you have to carry huge amount of weights in space and you have to reuse it. You cannot say that, okay, I've flown one rocket, now this thing falls away and you start making a new one. No, it does not work like this. So what they do is that when this rocket takes off, it goes into space, it launches its payload in space. These 3 things are separated out even before that. Just before that, the three things are separated out. These 3 things, they come and they land. Okay. For instance, this particular thing will come and it will land like this. Okay. That they have achieved a mastery in doing this type of things. So the entire thing has been recovered. It will come right in the same place wherever you want it. You can reuse it. So, and what is the fuel they are using? They are using kerosene oil. Okay, some basic kerosene oil and LOX, liquid oxygen, as the the supporter of combustion. Okay, so this is how they do the things. This I can skip, it's not required. Rudra, theek tha na abhi tak? Hello? Somebody
Yes,
replied?
sir.
Yes, sir.
Okay.
Yes, sir.
Okay, now let me come to something. My talk is over. Let me come to something which is very useful for you as students. Sometimes people ask about softwares. Okay. If you are in BSc final year or in MSc, sometimes you want to do some projects by yourself. This is one interesting thing. There is a CLIA exercises, contemporary exercises in astronomy. You can go to the website. There are several simulations. There are supporting documents also in astronomy dealing with radio telescope, infrared telescope, visible telescope, so many things. You can download it on your computer. You can do a very nice project. And that project could extend over six months. Okay, so this is a serious business. Those of you who are senior students. Okay, in fact, you can mention in your interviews if you are going for some astronomy institute or astrophysics institute, you can tell them that you have done this. Okay, if in case you want to do some basic things, you want to see a virtual planetarium on your desktop or your laptop, you can download Celestia. All these things are freely available. You don't need any money. Okay, you don't have to pay anything. There is another software by the name Stellarium. It's a sky map. In this case, you have to change your location. There is a particular window here. Once you install it, there is a particular window where it says location. The default location is France. You have to bring it to your place, like Kurukshetra, if you are in Kurukshetra. After that, it will show you the real, almost like a real situation of your place. Means how the stars are, where the stars are. at a particular time. This is a very interesting website. I recommending it to almost everybody, especially in this epidemic era where we are not able to do experiments in physics or any other branch. This is a fantastic website. In fact, there is an endless list. I'm not going to talk about everything, but go to this website. There are lots of simulations in physics and electronics. I can guarantee this thing that once, if you have gone through all these simulations, at the end, you will become expert in electronics, definitely, and you will have a good understanding about physics. Okay? You don't need any teacher, any other help. Just take some particular books which are required. Otherwise, some basic notes are mentioned on this particular website. It covers almost the entire electronics. It covers good amount of physics. Have a look at this particular website. In fact, take a photograph of this thing. I do not know whether this entire lecture is getting recorded, but then you can take a photograph of this particular slide. Okay.
So lecture is recorded.
Okay, so that is good then. You can share it with the students. Okay,
Yes,
so
sure.
I'm through with the lecture. If there are queries, I will address the queries.
So participants, lecture is completed and it's open for the discussion. If you have any query or you want to ask something, please. Although lecture is self-explanatory and descriptive. So if no queries, so it's time to thank you, sir, for this very interesting and scientific lecture. The lecture you delivered is like a story, which definitely we don't want to stop, and we want to keep listening on it. You beautifully explained the origin, evolution of our universe, how this observation science called astronomy do wonders, and how it explained the existence of life on Earth or the prediction of the life on other planetary. Yes, Divya?
Yeah.
Okay. So you wonderfully overview the involvement of the biology, chemistry, and mathematics, and obviously the physics to understand the space, science, and astronomy. You also explained the advancement in science technology for getting the Google images, getting the weather forecasting information, space information, etc. The images of the sun you captured at different wavelengths are very beautiful to look at. And the glimpse about the actual rocket science that you told in a very simple language. Thank you for everything, sir.
Okay, thanks. Thanks a lot. Okay.
Dr. Suman?
Yes, Meera ma'am.
Okay. Thank you very much, Professor Sahajpal ji.
Thank you, madam.
Your talk was really very informative. I must say it is in about every segment of the talk. I personally liked it, and the main thing when you talk कि chemistry में elements का कैसे origin हुआ, I personally like that, and I would like to communicate to my students also how this lecture was going to help in discussing the chemistry also. Another part was that in the end, when you have listed various softwares and the website in the online era of education.
Yeah.
I think, that is very wonderful, and the student must have been benefited. Thank you very much for sparing your time for the WIS platform. Thank you, Professor.
Thanks a lot. Okay. So I'll